Welcome to Trinath chemistry classes. In this video I am going to discuss about intermediate first year chemistry topic acids bases. In this acids bases concept I am going to discuss about solubility product. In my previous video I have discussed about solubility equilibria and sparingly soluble salts. So sparingly soluble salts means based on the solubility of a ionic solid in water, salts are classified into three types. Completely soluble salts if their solubility is greater than 0.1, completely soluble salts, and slightly soluble means their solubility is between 0.1 to 0.01 to 0.1, and if they are called sparingly soluble if their solubility is less than 0.01 mole. And the solubility product is related to the sparingly soluble salts. Now let us consider a sparingly soluble salt such as AXBO, and which gives on dissociation X into AY minus plus Y into BX minus X plus. Right? So as it is a undissociated form, this is the dissociated form. I have already discussed in my previous video. In case of sparingly soluble salts, there exists an equilibrium between the dissociated form and associated form. Dissociated form and undissociated form. If you take a sparingly soluble salt like AB, then there exists an equilibrium between A plus and B minus. So here there is one. Suppose if it is A to B, then what will happen? 2A plus and B 2 minus. 2A plus and B Y minus. Suppose if you take A to B3, so there exists an equilibrium between 2A into 3 minus plus 3B into 2 minus. So there exists an equilibrium between the dissociated form and undissociated form. Dissociated form and undissociated form. If we write the equilibrium constant for this, K is equal to, then what will happen? A into Y minus by X, B X plus Y whole by AX into B. If we take this word to this side, then what will happen? AX by is equal to AY minus X BX plus whole power. So here K is a constant, and as this salt AXBY is sparingly soluble, its concentration remains same. That's why these two together we are calling it as a new constant. That's one we are calling it as the solubility product constant. Right? Solubility product constant, or we are calling it as the solubility product. Right? This is one we are calling it as the solubility product or solubility product constant. So if you take a sparingly soluble salt like this, A to B3, then what is the KSP? KSP is equal to, so if I write 2 into A3 minus plus 3 into B2 minus, that's why A3 minus whole square into B2 plus into, this is the solubility product constant for this A to B3 salt. If you take AB type of salt, so A gives A plus and B gives B minus, then what is the KSP value? KSP is equal to A plus and B minus. So solubility product is the product of the concentrations of ions present in a saturated solution. We know that solutions are classified into three types. One is saturated, another one is unsaturated, third one is super saturated. So saturated means, suppose if a salt, if you take a glass of water and if it can dissolve 1 spoon of sugar, if you dissolve 1 spoon of sugar, then the solution is saturated. If you dissolve less than 1 spoon, that is, then it is a unsaturated. If you dissolve more than 1 spoon, then it is a super saturated solution. Super saturated solution. Right? Solubility product is the product of concentrations of ions present in a saturated solution. Present in a saturated solution. When this sparingly soluble salt is dissolved in water, very small fraction of that ionic solid is sparingly soluble solid is salt is soluble, that's whatever soluble, that one forms a saturated solution. That's why we can define the solubility product as the product of the concentrations of ions ions present in a saturated solution, present in a saturated solution, that one we are calling it as the solubility product. Now let me explain one more term, that is ionic product. I have already discussed ionic product of water means what? Product of the concentrations of ions present in water, right? Ionic product is the product of concentrations of ions present in a solution. That one we are calling it as the ionic product. Whereas another one we have already discussed, this is the solubility product. Solubility product is the product of concentrations of ions present in a saturated solution. Now what is the difference between solubility product and ionic product? Ionic product and solubility product both are the products of concentrations of ions only, but in solubility product this is equal to the product of concentrations of ions present in a saturated solution, whereas in ionic product is the product of concentrations of ions present in a solution. This solution may be saturated, may be unsaturated, may be supersaturated, but here the solution always should be a saturated solution. Now, what is the significance of this solubility product? Generally, ionic product is denoted as QIP, whereas solubility product, I have already told, it is denoted as KSP. If for a solution, if KSP is equal to KIP for QIP, then the solution is a saturated. If KSP is greater than QIP, KSP is greater than QIP, then the solution is unsaturated. If KSP is less than QIP, the solution is supersaturated. Based on the solubility product concept only, in qualitative and inorganic qualitative analysis, cations are classified into 6 groups based on one of this concept, that is solubility product. So, if K solubility product is equal to the ionic product, then the solution is saturated. Maybe in intermediate public examination point of view, we may require, they may ask like this, what is solubility product? Then we have to answer. Thank you for watching Trinath chemistry classes. Please like the video, share and subscribe the channel.